Separating funnel. Most of the matter around us is a mixture of two or more components. Mixtures are either homogeneous or heterogeneous. Homogeneous mixtures are uniform in composition like air, and heterogeneous mixtures are not uniform in composition like oil in water. Homogeneous and heterogeneous mixtures can be separated into their components using different techniques based on the type of mixture and difference in the chemical properties of the constituents of a mixture. Separating funnel is one of the techniques that is used for separating the components of a mixture between two immiscible liquid phases. One phase is the aqueous phase and the other phase is an organic solvent. This separation is based on the difference in the densities of the liquids. The liquid with more density forms the lower layer, and the liquid with lesser density forms the upper layer. Materials required: beaker, filter funnel, separating funnel, mixture of oil and water, and stand with a clamp. Procedure: first, take the separating funnel and clamp it on the stand. Now, take a filter funnel and place it on the mouth of the separating funnel. Pour the mixture of oil and water into the separating funnel through the filter funnel. Then remove the filter funnel from the separating funnel and close the separating funnel using a lid. Now, take the separating funnel from the stand. Invert the funnel and shake it gently and slowly open the stopcock of the funnel to release the pressure inside the funnel. Again, place the separating funnel in the stand and allow the two liquids to separate completely. We can see that oil forms the top layer and water forms the bottom layer. Now, take a beaker and place it below the separating funnel. Remove the lid on the mouth of the separating funnel. Open the stopcock of the separating funnel and pour out the lower layer of water carefully into the beaker. Close the stopcock as the oil reaches the stopcock. Take another beaker and place it below the separating funnel. Open the stopcock and now collect oil from the separating funnel. Finally, label the two components transferred into the beaker as water and oil. From this experiment, we can infer that the immiscible liquids separate out in layers depending on their densities. Since water is the denser liquid, it falls to the bottom and forms the lower layer. As oil is the lighter liquid, it forms the top layer. Simple distillation. Simple distillation is a method used for the separation of components of a mixture containing two miscible liquids that boil without decomposition and have sufficient difference in their boiling points. The distillation process involves heating a liquid to its boiling points and transferring the vapors into the cold portion of the apparatus, then condensing the vapors and collecting the condensed liquid in a container. Materials required: porcelain chips, mixture of acetone and water, 250 ml and 100 ml RB flasks, heating mantle, vacuum adapter, distilling head, thermometer adapter, water condenser, and stand with clamp. Procedure: take a mixture of acetone and distilled water and pour it into a 250 ml RB flask. Clamp the RB flask to a stand and place it in a heating mantle. Take some porcelain chips and put them into the RB flask. Connect a distilling head to the RB flask and a thermometer adapter with thermometer to the distilling head. Connect a water condenser to the outlet of the distilling head and a vacuum adapter to the water condenser. Now, connect a 100 ml RB flask or receiver flask to the vacuum adapter. Place the RB flask into a beaker containing water. Then, connect a rubber tube between the tap and the inlet of the condenser to allow cold water to enter the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the mixture to boil. At 56 degrees Celsius, acetone vaporizes and the vapors pass through the condenser and condensation occurs. The acetone is collected in the receiver flask in the liquid form and water is left behind in the distillation flask. Acetone boils at 56 degrees Celsius and water boils at 100 degrees Celsius. Therefore, the miscible mixture of acetone and distilled water can be separated only by simple distillation. Since the acetone and water mixture separated only by simple distillation. Since the acetone and water mixture forms an azeotrope, the procedure needs to be repeated to obtain the components in the pure state.
The solution is heated until it boils. The liquid evaporates and then is condensed into another container. It can be used to separate a mixture of a liquid
Fractional distillation. Fractional distillation is used for the separation of a mixture of two or more miscible liquids for which the difference in boiling points is less than 25 Kelvin. The apparatus for fractional distillation is similar to that of simple distillation, except that a fractionating column is fitted in between the distilling head and the RB flasks. Materials required: mixture of ethanol and water, 250 ml and 100 ml RB flasks, stand with clamp, fractionating column, distilling head, porcelain chips, thermometer adapter, water condenser, vacuum adapter, and heating mantle. Procedure: take a mixture of ethanol and water and pour it into a 250 ml RB flask. Take some porcelain chips and put it into the mixture. Now, connect a fractionating column to the RB flask and clamp it. Connect a distilling head to the fractionating column and a thermometer adapter containing thermometer to the distilling head. Connect a water condenser to the outlet of the distilling head and clamp it. Now, connect a vacuum adapter to the water condenser and a 100 ml RB flask to the vacuum adapter. Clamp the RB flask and place it in a beaker containing water. Now, connect a rubber tube between the inlet of the condenser and the tap to allow the cold water to enter. Connect another rubber tube to the outlet of the condenser to pour the hot water from the condenser to the sink. Open the tap so that water flows through the tube and fills the condenser and then comes out through the outlet. Set the temperature of the heating mantle and heat the contents of the RB flask. At 78 degrees Celsius, ethanol vaporizes and the vapors rise through the fractionating column and pass through the condenser, and condensation takes place and ethanol gets collected in the receiver flask in the liquid form and water is left behind in the distillation flask. Therefore, the separation of two or more miscible liquids for which the difference in boiling point is less than 25 Kelvin and can be done only by fractional distillation. Since ethanol in water forms an azeotrope, the distillation has to be repeated to obtain the pure components.
In this video, let us look at how we can separate the inks in different colored markers by using chromatography. Using a filter paper, we first draw a start line about 1.5 centimeters from the base using a pencil. Next, we apply small but concentrated spots of our samples on the piece of chromatography paper. This is important to ensure that there is enough sample as the individual components will be diluted when they move along the paper. If the sample spots are too large, it will be difficult to distinguish the individual spots on the chromatogram. The spot is made as small as possible so as to prevent tailing as well as smudging when the inks or dyes are being separated. Chromatography is the technique used to separate small amounts of substances from a mixture based on the different solubilities of the components in a particular solvent. Now pause the video and think about what are some of the advantages of using chromatography over the other separation techniques you have learned. The principal advantage of using chromatography is that only a very small sample is required for the analysis. To begin, we first add a small amount of a suitable solvent to the beaker. In this case, why do you think water is a suitable solvent? The choice of solvent depends on the type of sample we are using. In this case, as we are using water-based inks, water is a suitable solvent because the inks are soluble in water. Moving on, we now place the chromatography paper and immerse it in the solvent. We also must not forget that we have to cover the beaker with a lid. Why do you think this step is important? Covering the beaker with a lid minimizes evaporation of the solvent as it travels up the chromatography paper. You can see that as the solvent moves up the chromatography paper, it carries the different dyes along with it. Dyes which are more soluble in the solvent will migrate faster and further along the chromatography paper. Here we see the solvent front moving upwards. When the solvent front has reached near the top, we then remove the chromatogram and mark the solvent front with a pencil line. Why do you think this step is important? The applied spots will be traveling up the chromatogram relative to the measured solvent front. Knowing the solvent front is important for the calculation of RF values. Notice that I also let the solvent front run as high as possible before removing the paper. The further the solvent front from the start line, we can ensure a better separation for the spot of the dye for accurate identification. However, we cannot let the solvent front overrun, otherwise we cannot measure the actual distance covered. Let us take a look at the results. We find that many of the inks are made up of a mixture of dyes except for the yellow one because there is only one spot. We can say that the yellow ink is pure because it is only made up of one dye. The black ink is a mixture of 3 different dyes, of which the blue dye is the most soluble in the solvent as it has traveled the furthest. The blue ink is a mixture of 2 different dyes, one blue and one purple, and the purple dye is insoluble in water, that's why it remained at the start line and did not migrate up the paper. For the dyes that were not well separated, we can consider changing the solvent. Now let us repeat the experiment, but this time let's take a look what would be the outcome if we had drawn the start line using ink instead of pencil. We can see that the ink, being soluble in the solvent as well, will also move up the chromatogram and complicate the results. Summarizing what we have learned so far, how do you think you will answer these two questions? Let us repeat the experiment again, but this time let's see what happens if the ink spots are below the solvent level. We observe that the different inks do not get carried up the paper, but instead dissolve in the solvent. The inks cannot be separated. It is therefore important to ensure that the sample spots are above the solvent level. This is to prevent the sample from dissolving in the solvent before it is carried up the chromatography paper. This would prevent the separation of the different components of the mixture. Now let us summarize the 3 different experiments we have done in this video, and hopefully you have a better idea of how chromatography is done. Thanks for watching.